G is sine x, tan x. Sorry, I had another typo in this one. I don't know what happened. I tried to fix it last year and I forgot to fix it. This one is supposed to be cos x. That's, again, just a typo. I had 1 minus cos squared, and it should be cos x in the denominator. I'll fix it next year for sure. And I think I posted solutions for the identities in the Google Classroom as well, so you can take a look there. Okay, so that's the question. Sorry, I had to correct that. Now, let's take the left side and the right side. So when I write the left side, I have sine x tan. Okay, I'm going to definitely change the tan to sine over cos. So when I'm doing that, okay, right side, I have 1 minus cos squared, which I already know is sine squared, right? So I know that's Pythagorean identity. You have to recognize Pythagorean identity, 1 minus cos squared is sine squared. And this is cos x. So that might come in handy because I see a sine over here. That might be okay. All right. So then when you write it, analyze it. Kind of go, what am I going to do? That's your planning time. So I'm going to take the tan, and I'm going to write sine over cos. Okay, that was what I planned first. Then again, if it's fractions and whole numbers, I used to always tell my students do this. So you're going to do numerator times numerator, denominator times denominator. So I'm going to get sine squared like that. Okay. And I compare. What's really good about this? What's good is that the denominators are the same. Beautiful, gorgeous, I'm almost there, right? Denominators are the same, so compare. Go, yep, their bottom denominators are good. The numerator, gee, I wish they were the same. And what are you going to say to me? They are the same, because 1 minus cos squared is sine squared. Sine squared is 1 that's the Pythagorean identity. So now just fix one of them. Do you want to fix the right or the left? Doesn't matter? Okay, I'll fix the right. So I'm going to write this one as sine squared. I need your last step to be identical. So fix one or the other, but they are the same. The numerator is the Pythagorean identity, so therefore left side equals right side. QED or the tombstone. Okay. Not bad, right? So hopefully you're like, okay, this isn't looking as bad anymore. Let's try it again. So we're on to H. That's okay for this one, right? Once you start to recognize this Pythagorean identity, it really helps, right? 1 minus cos squared is sine squared. 1 minus sine squared is cos squared. Okay, and that's one of the ones I need you to memorize. Okay, we're moving up. Sorry, is that too fast? Too fast. Okay, yeah. Still someone out? No. No, he's here. Okay, yeah, really quick though. Okay, over here, left side. And this is sine x minus, oh, I'm writing it twice. So that's definitely common, right? So when I'm writing, I'm like, I can feel myself writing it twice. So don't just write it like you're copying it. Write it and analyze. I can see a common factor, right? So right away, I don't even know what's going to happen, but I feel like common factoring that out, right? I don't even know what the other side is, but you have an instinct to go, I can simplify this, so I'm going to go 1 minus cos x, common factor. And I have a sine. I didn't even look at the other side for a clue yet, but I know that's going to help. Okay, then take my right side, and you go 1 plus cos x over sine x. And I go, I can't do anything with that. There's nothing. You can't change it. Pythagorean is only for squared. They're not squared. Can't do anything. So stuck. Okay, I'm going to go back here and just finish this one off. So this one's gone. This one's gone. It's 1. I'm going to write down. So I got sine x over 1 minus cos x. Darn. Now what? Yeah.
Sine it. Oh, wait a second. Never mind.
I know, because it's not squared, right?
I did that step.
Yeah, okay, so it's not squared. You can't do Pythagorean. We're stuck. Full stop. You cannot do Pythagorean unless they're squared. So no Pythagorean. What else can I do? Can't reduce sine and cos anymore. Okay, this one is a bit of a tricky one. When you're absolutely done, like there's no squared, so no Pythagorean, do not force it. Okay, no Pythagorean, cannot force it. What I wish, and what did I look at here? I went, oh yeah, my denominators are the same. That's happy. My denominators are the same. That's really, really happy. Now, can I make these denominators the same? I wish those denominators are the same. And you go, but I can't. They're so different. Yeah.
Can you reciprocate?
We can't because whatever you can't do whatever you do to one side, you do to the other. But you are in a fraction allowed to do lowest common denominator. Can I multiply this one by sine x? Is that wrong? Have I done anything mathematically wrong? Anything mathematically wrong with that? No. So if I multiply the top, and this only works for fractions. So if I multiply the top and the bottom by sine x, I will have 1 minus cos, right, on the denominator here, and sine x. What can I multiply this one by to get them to be the same? Right, so if I multiply each one of them by the other denominator, what is this denominator now going to be? Sine x, 1 minus cos x, and here, sine x, 1 minus cos x. Are they the same now? Right, because the one above, the goal was the denominators are the same. Here, I can't make the denominators the same, but you are allowed only with fractions. Right? So if this was sine x with nothing in the denominator, I can't. Doesn't work. But if you can multiply the top and the bottom by the same thing, you're technically only multiplying it by 1. So you're not doing anything mathematically wrong. You're not bringing anything left to right, none of that stuff. So then here, what have I got on the top? Sine x is sine squared. Don't cancel it. Don't cancel it. My goal was to get this guy. Look, people go cancel. No, no, no. I want the denominators to be the same. That was my goal. See how beautiful that is? They're the same. Here, what's 1 plus cos times 1 minus cos squared? Cos. What's 1 plus cos times 1 minus cos? Yeah. 1 minus cos squared. And then, wait. That's where I left you here. That's exactly the same question here. Look, see? For the numerator. For the numerator, sine squared is 1 minus cos squared. So then change one or the other. Do you want to change? I'll change this one. So this one is sine squared. And look, my goal was, I know you feel like canceling it, but it's not, we're not just canceling, we've got a goal in mind. We're trying to keep the denominator so that they stay the same. So it's different than just canceling. And now they're the same. So therefore, left side equals right side. This one is a different one. We're going to star that one because that one's a little bit harder because we had to create our own lowest common denominator. And it's because we were stuck. We were backed into a corner. We had nothing else we could do. So we did lowest common, right? So I'm going to say lowest common denominator for both of them, here and here. And then that created a wonderful thing that was the same. Okay, and that's a nice little trick to use. Any questions with that? Okay, so when you run out of the squared and the other stuff, then say, can I do lowest common? That's a possible way. No other questions?